So I thought it'd work these three examples. This is out of the textbook on page 61. It's in section 1.4, and talk about how the domain follows, because this can be very confusing. And I wanted to get you to some practice. So this is when somebody just asked me about one of the Bible math questions where it's just like number 33. So I thought I'd do 33 for you and 34 for you, and then we'll look at 35, which is slightly different. And to get you some ideas about how the domain of these, when we apply algebra or composition to functions, how that affects the domain. Okay, so somewhere here, I've got it's not a screen I can write on. So I wrote those down here. Let me stop my share and I'll open up I think it's Paint. Share my screen. Okay. So 33 said the square root. Let's see, we got here. I'll use Paint's. Well, maybe I'll use Paint's program. So let's see. P of X is 1 over X cubed, or 1 over the square root of X. And M of X is X squared minus 4. They're asking us to find the domain of P of X divided by M of X. So we've got some things before we get there. Let's think about this. So I know I can't take the square root of a negative number, and I can't divide by 0. So for P of X, X has to be bigger. X can't be 0, right? So it has to be bigger than 0. And I also can't take the square root of a number, and if it's bigger than 0, that works, right? See, not being a negative number, X could be 0, but because of the square root, see, if this was just the function with square root of X, the domain would be 0 or bigger, right? Actually, you could include 0 and go to infinity. That would be valid in that domain, but because it's in the denominator, the square root in the denominator, it can't be equal to 0. So that's an open interval. If we want to do interval notation, this is the same thing as this means the same thing as open 0 to infinity. And then in this one, this is no issues. This can be, there's a polynomial. And I don't know if you remember from algebra 2 how that factors the X plus 2 times X minus 2. And that would have zeros at -2 and +2. So how do I want to approach this? Let's do it this way. Rather than thinking about the graph, let's just make a table. So X -2 is a 0 for M of X, and +2 is a 0 for M of X. And if I plug in a number smaller than -2, like -10, that will be here. Let me get a pointer going. That might be better than mouse. There we go. If I take a negative number like -10, square it, it's going to be a big positive number, -1. That'll be this will be positive here. Let's board back here. Come on. We talk to it in a squeaky voice, maybe it'll work. So that's a positive number. And if I pick a number between -2 and 2, like 0, well, that 0 minus 4 is negative, right? So that's a negative. And greater than 2 will be just like a positive with negative. I mean, +2, greater than +2, pick 10, be a positive number is what I'm trying to get at. Okay, so that doesn't come into play as domains, but it'll help us in the future here. So P of X is 1 over the square root of X, and M of X is that X squared minus 4, and I'll write that out as X minus 2, X plus 2. So we already know that this domain from there, X has to be bigger than 0. Down here, so whatever the top is, I know the bottom can't be zero. So, but I've got some number on top, right? On the bottom, I could ask myself, when does x minus 2? We don't have to worry about the square root of a negative number here. We just got to worry about when is it equal to 0. So at positive 2, the denominator is equal to 0, and at negative 2, it's equal to 0, negative 2. So that's not, those two are not included in the domain. Now, we've already, so x can't be negative 2, x can't be positive 2, because it's in the denominator, right? And now, because P of x has a domain x is greater than 0, we don't even have to worry about negative 2. So we just got to worry about this. So the problem says, hey, I can go from, I'm going to write this interval notation. I can go from 0 up to 2, but then I've got to skip over 2 and go to infinity. Okay. So like this would be 0 to infinity if I did this as an interval. So what we got to do is break that up because of the 2. All right, so that's the domain of that composite function. And I could graph it. I could throw this into Desmos and let's take a look at it. Tell me, I'm going to pause this and do that for you. It's still recording. It's been recorded. Sorry. I thought I had it recorded stopped. Oh, well. I hope you jump over that. So you remember how we got 0 is 0 to 2, and then we jumped over 2 and got to infinity. And this is what we can see with a graph. We can see how it's not there too. It's going down. It's got a vertical asymptote, and we'll learn about that if you don't already know about that. And then it does the same thing at 2. It's got that vertical asymptote there that's not included in the domain, which is different from the 2 original functions, right? So that's how that affects it. And all right, so now let's talk about, let's see, the next one was P of M of X. So P of M of X. So that means I'm going to nest the polynomial inside that P of X. So that's going to be 1 over the square root of here. I'm going to write it out. I'm going to write it as x plus 2, x minus 2, or x minus 2, x plus 2, instead of writing the x squared minus 4. This will help us get there when we think about it. And you remember that number line I made for the m squared for the x squared minus 4. It was at negative 2 and positive 2, and it was positive here and negative here and positive here, right? So what's the domain of this composite function? Well, I know I can't divide by 0, right? That's a problem. That's a problem. And that happens when x equals negative 2, when x equals positive 2. So that's not in the domain. Those are not in the domain. And I can't take the square root of a negative number in any place between negative 2 and positive 2. This function here is negative. So that would be 1 over the square root of a negative number. Can't do it, not in the domain. But anything less than +2, -2 would be positive. Anything greater than +2 would be positive. So the domain of this nested composite function is going to be -infinity until -2. And those are both open. And then we got to skip over anywhere between -2 and +2. And that'll be 2 to infinity. And we can check this. We can have Desmo show us this. And I'm going to kind of leave that writing up there. And I'm just going to change that y function. I'm going to change it here. I'm going to change it to P of M of X. P of M of X. And there we go. You see how it doesn't graph between -2 and +2? Here, let's get a pointer going. See how it doesn't graph between the -2 and the +2, and that agrees with what we're looking at. Okay. And then M of X, let's see here, let's do the next one. So let's clear this out. Here all we're writing. Here we go. And then I don't want to give away the farm here. I want to think about it analytically before we look at the graph. So the next part was to reverse it. We were going to take, and honestly, guys, this next part with reversing it can be the hardest part about it. So I'm going to do M of P of X. M of P of X is what they want me to do. So that tells me I'm going to take this 1 over the square root of X, square it, and take away 4. So before we get to doing the algebra, we know the domain of this X has to be bigger than 0, or 0 to infinity, right? This is not going to go away, and we'll see that in a minute. Now, if we square this, it says square it, so 1 over the square root of X times 1 over the square root of X, well, that's 1 over X, right? So this function looks like this. So you would think, looking at that function, X couldn't be equal to 0 and would be good. And the domain would be, so the domain in interval notation would be -infinity to 0 and from 0 to infinity. We've got to skip over the 0. So then let's graph it and see if I'm right about this. I'm not, but we'll talk about why here. So I got to switch this. I got to switch this to M. Make this be P. And let's graph it and see what we see. So this is supposed to be, looking at our last analysis, I should be seeing some green graph over here on the left of the x-axis because that's that domain. But what we're seeing is exactly the same. Here, let me turn on P of X. You see how that's got the same domain? That's because even though we did it algebraically, even though we got rid of the square root algebraically, that domain limitation still holds. So keep that in mind as when you're talking about domain of composite functions. Those domain limitations never go away. I mean, if you wanted to do this numerically, if I wanted to plug in, if they were asking me to find here, they were asking me to find M of P of -2. Let's do a number we take the square root of, except that it's going to be negative. And do that. Of 4, -4. If I try to drop that into the square root, 1 over the square root of X, I can't take the square root of -4. So that limitation still goes on. So I can't get an output. If this had been +4, I would have been good to go. I could have got 1 over 2, and then I could have dropped that into the 1/2 squared -4, because that's the outside function, right? And we would have got an answer. What is it? 1/4 -4, so -3 3/4, right? So it would, if it had been positive, no problem, but that, see, that original domain didn't go away. So I hope that makes sense, because that's the big thing. That's the tricky part about these domain limitations. It doesn't go away. I mean, I could do, I guess if that's good enough, you can stop the video and go on with your work and not listen to anymore. I'll take the time and I'll work through 34 and 35 the same way in case somebody wants to, is a little confused or wants to see more. I won't be offended if you don't watch it. Let's see. So the functions are new. Let's see, let's change those functions here on the graph so I can double check myself. Well, it's a 1 over x, that stays as put, but then this gets a reflection going on, doesn't it? 9 minus x squared. This is number 34 on that page. Okay. Oh, it's graphing it. Ah, giving away the thunder. If we do this, if we do the division, that m, that what was it? It was p over m. So if I do 1 over the square root of x over 9 minus x squared, again, this bottom factors to 3 minus x and 3 plus x because it's difference two squares. So x can't be 0, right? Actually, x has to be bigger than 0. In this case, when x is positive 3, it's a 0. And when x is negative 3, it's a 0. But the negative 3 is not in the domain, so of the 1 over x. So we have to say 0 to 3. Really, it's just like that other question. It's just with different numbers. And then 3 to infinity. Okay, and we skipped over. So then now let's do some switcheroonie, switching things around. Oh, well, I guess we should look at the graph. Let's look at the graph of that. Here, this is the division. I am recording, right? So P of x divided by M of x to graph it. And yeah, that's exactly what we're seeing. See if we get in the two vertical asymptotes. Okay, let's do P of M of x and see what happens. I don't know, it's probably in a different order, Dan. P of M of x. Here we go. Let's figure out what's happening here. So we're nesting. I think this is the one that's a little wonky, right? It's nesting away. And where is my board pen? Did it fall on the floor? Did I keep it in a pocket? Here it is. So let's see. I'm gonna take the P of x. P of x is on the outside. M of x is in the inside. So let's see. So I know that denominator is equal to 3 minus x. I don't know why I wrote m. And 3 plus x. So let's make that little number line so we can see what's happening here. So we know this is a 0 at -3. We know it's a 0 at +3. So if we plug a number less than -3, it's going to be a big number, right? -10 squared, that would be 9 minus 100. That's negative. We drop a number inside between -3 and 3, like 0. Well, that'd be a positive number. And then bigger than 3 is back to being a negative number. So this tells us that in between -3 and +3 is where it works. So, and it can't be equal to 3 because that's, or -3, because that's where we get the can't take the square root of negative number. So the domain of this composite function here is going to be -3 to +3, not going off to infinity. So we should just see a graph in between those two things. Let's see. So I do that right. I nested the 9x squared into the square root. Yep, let's see what happens here. And sure enough, from -3 to +3 is the only place this is getting graphed. Okay. Here, now let's switch. I'm going to switch it up so we're ready to go. Clear this board off. Then we'll get, let's see. So now we're going to nest. Now we're going to nest one. I'm going to do 9 minus 1 over the square root of x, and then I'm going to square it. So that old domain limitation of x has to be bigger than 0 is the one where it's going to play along here. And so that's what we think is happening, right? And does you want to think about anything else here? I think, so we don't have to worry about square root of negative numbers. That would become this. X can't be 0, but we're saying the old domain's got to be bigger than 0. So that's what we should be seeing, right? We should just be seeing a graph off to the right. Let me just graph this one. Yep, see, we're seeing it. That's it going off to the right. Okay, so that confirms it. Have we done everything? We did the other one. We did the division. I think this one's good. I think we've got this done. Now, the last one I was going to do was number 35.